Alright, so today we are going to talk about the quadratic formula. The quadratic formula is the last way to solve quadratic equations and finding the solutions. It definitely helps when it's one of those ugly questions and when we start getting into imaginary numbers, which we don't talk about in Algebra 1, but it helps us solve when you can't factor it and things like that. So here is our actual equation. This is the quadratic formula, all of it. So x equals, I always say opposite of b because it's not always negative. It is the opposite sign. So if it's negative, then it becomes positive. If it's positive, then it becomes negative. So I say opposite of b plus or minus square root b squared minus 4ac all over 2a. Now again, remember, we are in the form of ax squared plus bx plus c equals 0, right? You have to have it equal 0 in order to plug them in. This actually can be sung to Pop Goes the Weasel. That's how a lot of people memorize this equation. I don't feel like you have to have this completely memorized, but in the future you will have to. Many times in my geometry classes, people already have it memorized from Algebra 1. Okay, so we're going to solve on top of this, here's a little link if you would like to listen. I'm not going to sing it for you. If we were in class, I totally would, but not when it's recorded. You guys don't want to listen to that anyway. All right, so we're going to solve these three equations. So we're going to start with number 1. Take a look at number 1. It already equals 0, so we're good to go. So what I'm going to do right now is just put everything that stays the same in already. So, and you don't have to, but just color coding wise, I'm just keeping it the same. So it is x equals negative b or opposite b. So b is positive 6. So we need negative 6. Plus or minus the square root of b squared. I'm just going to square it right now to give me 36. Minus 4 times a. Remember, if there's no number, that would be a 1. Times c, which is negative 16. All over 2a. Okay, so now what we're going to do is we're going to clean up what's underneath the radical. So we're going to keep it as negative 6 plus or minus. And then let's figure out what number is underneath the square root. Our denominator obviously is just 2 because 2 times 1 is 2. So be careful with these. The big part is that you do have to do this part first, or you just have to be careful of how you type this into your calculator. So I encourage students always to type that in first. So negative 4 times 1 times negative 16 gives me a positive 64. So this is actually 36 plus 64. Okay, if we keep going, then we would get this to be underneath the square root of 100, which we actually know what the square root of 100 is. It's 10. So if we start cleaning up the rest of this, you have 6 plus or minus. We ended up getting 10 here, and then divided by 2. Now these are actually two separate equations. You think about it as negative 6 plus 10, and then divided by 2, negative 6 minus 10, then divided by 2. This gives us our two answers. Negative 6 plus 10 is 4. 4 divided by 2 is 2. And then negative 6 minus 10 is negative 16. Divided by 2 is negative 8. So those are our two answers. If you look back at the original problem, this is one that you actually can factor. We would end up getting 8 and negative 2 to give you the 6, which then turns into 2 and negative 8. Okay, so you could factor this one. But again, specifies to use the quadratic formula. We're going to make sure we use the quadratic formula. All right, so let's look at number 2. This one's a little bit different. It's a little ugly. At least that's what I always call it, because it's all over the place, right? Remember, in order to do this, we need to have it equal 0. So the very first thing I'm going to do is move everything over to the left. Okay, so we would have x squared minus 4x plus 4 equals 0. Okay, make sure when you have to move things that you do put it in the correct order. You need x squared, x, and then no x. So I'm going to start setting it up the same way, just because I like color coding it. So we have x equals opposite of b. b is -4, this becomes a +4. Plus or minus the square root of b squared, which is 16, minus 4 times a. Again, a is 1 this time, times c, which is -4. Nope, sorry, +4. This is all under the square root. All over to a again, which is 1 again. Okay, so yet again, I'm going to try and clean this up a little bit. We have our 4, and then plus or minus square root of something. So we got to figure out what that something is. If you notice, it would become 16 and then minus 16 if we multiply -4, 1, and 4. That means underneath the square root, we actually have the square root of 0. And the square root of 0 just gives me 0, right? So right now our equation actually says 4, and you can think about it as plus or minus 0 over 2. But if we really dive into that, whether you add 0 or take away 0, you're still just left with 4 over 2, which gives me my only answer of x equaling 2. So if we think about these two as graphs, the first one would be something like this, right? And this one, when you only have one answer, it would be a parabola like this. With that being said, we could probably guess what this next one is going to give us. Again, this one is a little bit uglier, but not too much to clean up. All we have to do is move the 33 over. Okay, and yes, these are big numbers, but that's not an indication on what type of answer you're going to get. So we have x equals, and again, I'm just going to do the stuff that always stays. X equals opposite of b. b is 25, so we're saying -25. Plus or minus the square root of b squared. So we need to know what 25 squared, and 25 squared is 625. Minus 4 times a, which is 2, times c, which is 33, all over 2a. So don't let it confuse you. Just because there's a 2 out in front, that just means a is 2, whereas our other ones had a being 1. So we have -25 plus or minus the square root of, again, I'm going to keep 625, figure out what that other part is, and 33 times 4 times 2 ends up giving me -264. And it's all over 4 this time. Okay, so at this point, we got to clean it up a little bit. If we take 625 and we subtract 264, we end up getting the square root of 361. Okay, so at this point, we need to think about 361 and what it's divisible by. It's not divisible by 2 or 3 or 4 or 5 or 6, maybe 7. Nope. 361, and we can keep going through all of that, but if you keep going, you end up realizing that it can't be broken down. Okay, so we're left with x equals -25 plus or minus the square root of 61 divided by 4. Okay, if we can break this down, we should. This one's a little bit ugly. We're going to keep it just this way because there's nothing that we can really break it down with. So we keep it like that. Okay, so these are just uglier ones. This one actually, because we have what we have, is still going to be something that looks like this, but it's going to be in between numbers instead of it being like a solid -5 or a solid 2 or whatever it is. Maybe it's like a 10.1. Okay, things that aren't as nice. All right. As a little side note, ones that give me no solution. So we think about our no solution ones, right? I'm going to just drop down here. No solution. Okay, that happens when we get something like this. Let's just put it together. Let's say we had -2 plus or minus the square root of negative 4 all over 6. Okay? When you have something like this, a lot of us will think, oh, okay, the square root of negative 4 is 2. Well, if you think about it, we would need two numbers multiplied by itself to give me a negative, which negative 2 times negative 2 gives me a positive 4. We actually can't take the square root of negative numbers. Okay? And this is where one of our graphs that look like this happen, right? Or this, or any combination of not crossing the x-axis, right? Those are where those imaginary solutions come from, those non-real solutions that we keep saying are no solution, okay? So just as a little side note for that part, okay? So this is all of today's lesson. Is just really plugging into the quadratic formula and then simplifying. Tomorrow we will dive into it a little bit more and get some more examples of it. All right, now you can fill out your Microsoft forms for the day.